Hola todos. It's August 18th. All right, we are more than half away through August. Time flies. Nothing of concern. Nothing of concern. All right, let's do this. Decode ways. I don't remember this. A message containing letters A to Z can be encoded into numbers using the following mapping. To decode an encoded message, all the digits must be grouped, then mapped back to letters. Oh, I've done this before. Using the reverse of the mapping above. Yeah, I think I've done this before. Can be mapped to, great. Get him hydrated again. Hidratar, hydrate. So we can do 1, 1, 10, 6, 11, 10, 6, yeah. And then the grouping 1, 11, 0, 6 invalid because 0, 6 cannot be mapped to F. Given a string S containing only digits, return the number of ways to decode it. The answer is guaranteed to fit in a 32-bit integer. So we can decode 1, 2, and 1, 2. Yeah, I've done this. How did we solve it? 2 to 6. So 2, 2, 6. 2, 2, 6. 2, 2, 6. All right? 0 is no way. Neither of which starts with 0. Hence, there are no valid ways. So 0, because there's no valid ways. Okay, I mean, we can do DFS, right? Maybe that's what this is about, DFS. Maybe I shouldn't take a look at this. This kind of, yeah, if I've done the problem before, then people comment on these problems. And if I've done the problem before, I commented before, and people commented again, I can see the hints over here. Which actually I don't want to, so yeah, I think DFS can solve this. So basically we take 1 and we do the remaining, right? Or we take 2, we do the remaining. Or we cannot take 3, so we take 1 or take 2. And if it starts with 0 and you say, no, can do without. Yeah, let's take this example, right? So we take 2 and we say the total number of ways is the total number of ways we can decode 2, 6. And then from 2, 6, we, then we can memorize it too. So 2, 6 is 2 ways, right? So coming back here, that's 2 ways. And then we do 22, right? And then 6 is 1 way. We can do top down with memorization. And since the length is 100, now that would be easier to use indices. Yeah, it'll be easier to use indices. I can try both ways. I think a top down will be easier to write. And we surely can leverage the LRU cache, so I don't have to memo ourselves. Alright, let's take a look at this. Number decoding ways. Probably have a more difficult version of this, which will ask you to output all the decoding. Oh no, it's not any more difficult. It's the same thing. It's the same thing. So we want to have a DFS, right? And we have a left and right, int and int. Actually, I don't like left and right. I like low and high. And this one will return an integer, right? We do need to, from functools, import LRU cache. And this one will be LRU cache with none, the maximum size. So what do we do? All right, so if low is equal to high, right? If low is equal to high, then we say if S low is not equal to 0, if anything other than 0, we can return 1. Oh, we just return. So return 1 if this, else return 0, right? Now if low is smaller than high, then we say we're gonna do take by itself. All right. We say if so by itself, or so either by itself or take two, right? Either by itself or take two. So we say by itself. Basically, we say if s low, right, is equal to 0, then we return 0. Oh, well, I mean, this will be the same. If s low is 0, I shouldn't say if s low is not equal to 0, right? Then we can return, not return, so res equals 0, right? So if s low is not equal to 0, then res equal to dfs low plus 1 high, right? If s low is equal to 0, then we don't do this. And then we say, actually, no. If s low is equal to 0, then there's a no-go. Right, that's a no-go. We shall return 0, right? Yeah, if low is 0, that's a no-go. So we only go if the low is not 0, right? So if the low is not 0, then we say we either take 1 or take 2. So we take 1, we say, so res equal to, so we take 1, the dfs